Welcome back to my new video. So in this video we are discussing about the entropy. So what is entropy in according to the chemistry in the thermodynamics? So it is a thermodynamic quantity. एक thermodynamic quantity है thermodynamic quantity which measures random, we can say randomness or disorder of molecules of system. So entropy is a thermodynamic quantity which measures the randomness or the disorder of molecules of a system. Disorders मतलब suppose ये container है, suppose this is a container, there are some of the molecules and they are not in a specific sequence, they are not uh, we can say they are not in a proper sequence, or they are moving in a random, same as the gas molecule. If we compare the gas and if we compare the solid molecules, okay, suppose these are the uh, solid molecules. So the molecules of solid are tightly attached, are tightly packed, are in a proper order, are arranged in a proper order. But entropy is a thermodynamic quantity which measures the randomness or disorder of the molecules. Either it is gas system, it is liquid, or either it is a solid. So if we compare gas, liquid and solid, so gas entropy is greater than liquid and liquid's entropy is greater than solid entropy. So this is the relation between gas, solid and liquid. So entropy is denoted by the S. Mostly it is denoted by the S, and the actual value of entropy, we can say, if we would say absolute entropy, absolute 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 entropy is the absolute entropy we cannot measure. We cannot measure. We cannot measure the absolute entropy. It is not possible to measure the absolute entropy, but there is a possibility that, but we can measure we can measure we can measure change change in entropy. Change in S means S is denoted as the entropy. So change in S, we can uh, we can say calculate the change in entropy, but we cannot calculate the absolute entropy. Absolute entropy means the actual value of entropy. हम actual value entropy की calculate नहीं कर सकते, but if there are two containers and we can, if you want to say that what is the change between, what is the difference between the entropy of these two containers, so we can say we can measure that the change of entropy between the two containers. So the formula to measure the change in entropy is delta S is equal to Q upon T. Q upon T. This is a formula to measure change in entropy. If I would say one thing about the entropy, so entropy is directly proportional to temperature. Means entropy increases, temperature increases. Temperature reduces, entropy reduces. Again, if temperature increases, entropy increases. Entropy means the randomness or disorder of the molecules increases. If temperature decreases, the disorder or randomness or entropy of system decreases. So entropy is directly proportional to temperature, but there's a possibility that change in entropy is inversely change in entropy is inversely proportional to temperature. You can see the formula is inversely proportional to the temperature. Change in entropy is inversely proportional to temperature, whether entropy is directly proportional to the temperature. Q represent the energy and T represent the temperature. So the ratio of energy and temperature is called the change in entropy or change of entropy. What will be the unit? So if you find the unit, so energy, we know that energy unit is joule, and temperature unit is Kelvin. So joule per Kelvin is the unit of change in entropy, and another unit of change in entropy is calorie, calorie per Kelvin. Calorie per Kelvin is also a unit of change in entropy. But what is the difference? Joule, 1 joule upon 1 Kelvin, or you can say joule per coulomb, is equal to 1 entropy. If there is an option that 1 entropy is equal to joule per Kelvin, calorie per Kelvin, or none of these, so you will take joule per Kelvin is equal to 1 entropy. Okay, 1 entropy. So if we take a two containers, here we have two containers. Okay, the temperature of this is 80 Kelvin and temperature of this is 40 Kelvin. Here the system is present in this. Okay, here the system is present in this. If I would want to know that what is the entropy of this and this container, this first container and this is the second container, अगर मैं इन दोनों की entropy मालूम करूं, अगर मालूम तो नहीं कर सकते, बट इफ़ यू वुड से, इफ़ यू वुड थिंक, इमेजिन इसका टेम्परेचर 40 केल्विन है, इसका 80 है. सो 40 Kelvin temperature will have the less entropy than the 80K temperature. 80K temperature will have the less. 80K temperature means 80 Kelvin temperature container having 80 Kelvin temperature means it has more entropy. Whether the container having 40 Kelvin entropy or 40 Kelvin temperature, so this has low entropy. But here we are talking about the change in entropy, not entropy. हम क्या बात कर रहे हैं? चेंज इन इंट्रॉपी. सो इफ आई वुड से, अगर इन दोनों को मैंने एनर्जी प्रोवाइड की 20 जूल एंड 20 जूल, एनर्जी इज सेम, जस्ट द टेम्परेचर इज डिफरेंट. वी नो दैट फॉर्मूला ऑफ चेंज इन एंट्रोपी वी हैव Q by T for S1 and delta S2 is equal to Q by T. If you put the value, energy we have 20 joule, temperature is we have 40. In this 20 joule same energy, but temperature is 80 Kelvin. So 20 and 20, the answer we have 1 by 2, or you can say 0 or 0.5. If this, so the answer of this will be 1 by 4, or you can say 0.25. So entropy, the entropy of second container is 0.25 and the entropy of first container is 0.5. This means, this shows that entropy is entropy of container first is greater than entropy of container second. Okay, so this shows that if the temperature is low, change in entropy will be higher. If temperature is more, change in entropy will be less. ज़्यादा टेम्परेचर, चेंज इन एंट्रोपी कम, बट अगर ज़्यादा टेम्परेचर, एंट्रोपी ज़्यादा बट चेंज इन एंट्रोपी कम. कम टेम्परेचर, एंट्रोपी कम बट चेंज इन एंट्रोपी ज़्यादा. दैट इज़ द इनवर्स रिलेशन बिटवीन change in entropy and temperature, but there is a direct relation, there is a linear relation you can say between entropy and temperature. Okay, so this is all about the entropy.